Good morning, everyone. Can you hear me? Can you please say yes or no, somebody?
Yes, we can hear you.
Thank you, sir. Uh, Today, we are going to start our study of Ruby. That is part 5 of our course and the last one. So the last 5 meetings we are going to devote to Ruby, which is an object-oriented language. Okay, so maybe before we start anything else, it might be, or we just start from here. Let me see. Okay, one thing that I want to share with you is about literature, and we have a couple of books that are available, and at this moment I cannot share anything else with you, so let me keep it this way. There is this little screen on which I can show you a couple of books. The first one that I want to show you is this one here, the Ruby programming language that is written by Flanagan and Matsumoto. Matsumoto is the author of this language, and therefore the Ruby programming language is written by the author of the language. And I must say that this book has plenty of useful information for those who already know Ruby. It is not a textbook, and it is not appropriate for first contact with Ruby. What is appropriate for the first contact with Ruby is this book here. It is Dave Thomas with a couple of other people, Ruby Programming Language. This book is called Pickaxe. Pickaxe because of this pickaxe that you have on the front page. And you can download this book from the internet for free, actually. You can also buy a paper copy of it. And now, as you see, this book is not a small book. It is a big book. However, it has one nice property that I want to share with you right now. And this is that Ruby has 9,000 methods and approximately 100 libraries, so classes. So if you look the book like this, it has two parts that are practically the same size. The first part, this one from the beginning, is a very nice presentation of the language, very readable, plenty of examples for everything. You have programming examples, output of programs, etc. Very readable, very well organized. And then you have the second part, which is Ruby library reference. So as you see here, this is Ruby library reference. This is the second part of this book, and it is equally big as the first one. So the Ruby library reference is organized as alphabetical presentation of classes. So for example, if you want to see the class array, so here is the class array, it is alphabetically sorted, and then you have here presentation of all methods that you have in that class and also examples how to use them. And then you have plenty of such things that come after that. So all this is alphabetically sorted. So whenever you need any of these classes, you can easily locate that. And also they come with programs and with examples of their execution. So there are plenty of things that you can use if you have such a reference. So it is important to have not only the textbook for the language, but to have also the library description. And this is Ruby library reference. So I'm very much recommending this book. It is inexpensive. It is not expensive. This one that was recently the newest version was below $50. So that's it. If you take, and this is the version, in my case, 1.9. Now, this version is one that started using virtual machine. However, if you take 1.8, you can buy that for nothing because this is like previous version, and it is in 95% of material is exactly the same. So practically you can buy a paper copy of this big book for very, very little if you go to Amazon and try to see where you can buy used books that are going to be very, very cheap if you want to have one. Now, one more thing that I want to show you is this tiny little booklet that is called Ruby Pocket Reference. This is published by O'Reilly in this as a small book. So it is a small book, not the big one. And also it is $9. It is at least what is written here on at the back, that it is $9. So it is not expensive book. Why is this good? I always use these pocket manuals because they have alphabetically sorted all components of language. So if you know the language and you forgot something, then you can find alphabetically what you have here. These are just facts, 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 important facts. And you also have here and there one tiny little program that shows you how these things work. But mostly are definitions so that you can remind yourself what does exist, what is the syntax, etc. So this is pocket book, pocket reference in small format and inexpensive that has Ruby. Ruby has also variety of free books that are available on the internet, and they are listed on iLearn, and also you have them listed in the reader. And in addition to that, you have some of them that are posted on iLearn. I'm going to open that so that you can copy from there. So this is about literature. It is important to have this literature because it can easily be that some of you will have a job as Ruby or a Ruby on Rail developer. And if you want to work in that area, then you should have some reference book in your library. Not to mention that, as far as I know, almost everything that is written by Twitter is written in Ruby, and many other companies are using Ruby as the basic programming language. And Ruby is also important because it is a multi-paradigm language. It supports in a very nice way object-oriented programming, functional programming, and in fantastic way, procedural programming. So all three of them are supported and in a way that is indeed remarkable. So prepare to have the love affair with Ruby. Okay, so let us say a few words about introduction to this area. So the author of Ruby is Yukihiro Matsumoto. It is called Mats usually, and he explained the goals and design philosophy of that language. He said, I wanted a language more powerful than Perl and more object-oriented than Python. So he wanted to achieve that, and this is indeed achieved because in Ruby, there is nothing other than objects. Everything is object-oriented, and therefore there are no constants like integers that are different from objects. Everything is object. Number 3 is an object. So what we have is that if we work with Ruby, we have one tree structure that has the root that is something called object. Object is a class that has those things that are common for each and every object that you have in Ruby. So it includes all things that are common for all classes. And then all other classes are inheriting from object. So you have integers, you have floating point numbers, you have complex numbers, you have rational numbers, all of them. So you have first object, and then you have numbers, and from numbers you have different kind of numbers, and so on and so forth. So you have that inheritance from the parent classes is the method to develop the language, and also gives you the possibility that is not frequent in programming languages to expand the language the way you want. So for example, you have that from this parent class object, you are inheriting various things, and then you can continue inheriting that and specializing objects of your class according to your needs. So you can, for example, take the class array that has arrays of numbers, and you can say, okay, I'm going to expand this class array with new components, and these new components are going to be some methods that were not inside already available. On the other hand, if you have 9,000 methods, you better look for them before you start programming, because there is a huge probability that what you want to do already exists in library. So you should have access to library, because the library is giving you, of course, there is also online documentation, but to have a good book that has all libraries that are systematically presented, this is, in my opinion, very helpful in practical programming. Then it says, concentrate on the creative side of programming with less stress. That is 100% true. Any question? No question. Okay. So to concentrate on creative side of programming with less stress is something that is also true, because the syntax of language is very relaxed. You can have that very easy is to write programs, and you can practically start programming before you learn language. You will see that it is so simple that you can start today, even without any introductory knowledge, because simply it is very simple, and Ruby does understand all kind of variations on basic syntax. So it is very easy to create programming solutions using this. And then designed to make programming not only easy, but also fun. Well, this is something that is also true. So that's what the author is saying about his product. When you have various language processors, there are, of course, 3 ways how to implement a language. The first thing, you create a language, and then we have compiler. Compiler is compiling from source code to executable, and executable is executed by hardware. So we have source, compiler, executable, hardware. On the other hand, you can have that you don't execute directly on hardware, but execute in a simulated hardware, which is called virtual machine. So you have here virtual machine, which is a program that uses hardware. And then your compiler is compiling from source program to bytecode, which is this intermediate language, and then intermediate language is executed by virtual machine. So if you have virtual machine, the only thing that is running in your computer is the virtual machine, nothing else. So this is the way how Java works, or Ruby, or all such languages. And of course, you have the possibility to have interpreter. You remember that in Prolog and in Scheme, we used interpreters. So the source program was directly executed as it is written on hardware. So that is the way how this can be implemented. Now, in the case of Matsumoto, he initially made interpreter. So it was interpreter for Ruby, initially up to version 1.9. And then
Professor,
with version, yes, sir.
quick question about performance with Ruby. Is it on par with Python or is it faster? Because I know with Java, it has Python and Java are both pretty slow.
Performance.
Yeah.
Okay. Fibonacci numbers. Well, this was some time ago, but that was what was published. Ruby was running this in the case when they introduced the first virtual machine for approximately 12 seconds. Python was running this same program for 31 seconds. So it was 3 times faster than Python. What is today, you can measure yourself, but Ruby is performance aware. Of course, if you have Ruby interpreter, then it was terribly slow. Initial 1.86 that I had as the first Ruby that I used was like 1,500 times slower than C. So it was slow. But then they improved, as you see here, dramatically with the virtual machine. And then when they compared that to Python, it was 3 times faster. Is that current situation today? It is difficult to say because these are alive languages that have new versions that are all time improved, and performance is improved, of course. However, what you have to take into account that nobody is going to be as fast as assembly language program, okay, written by expert programmer. You cannot beat that. That's out of question. However, the next step would be C, which is like luxury assembly language, close to hardware, but still having all construct and abstraction that procedural programming offers. And then everybody else is in the next category. So if you want to see current situation, you have to do measurement that was done in current situation. So this changes. But that was at the moment of introduction of virtual machine. Now, this machine that I use here for this lecture is a new machine. So I installed yesterday Ruby on it. And this was 2.7.2 version. That's the current one. So this was 1.9.0. So 2.7.2 is, of course, completely different. So I'll show you that in a minute, but I want you to see that we have these performance relations that are rather big differences in performance actually between various of them. So we have languages that compile to machine language like Fortran or C or C++, and basic features are maximum optimization of the compilation process, high performance of executable code, efficient use of hardware, etc. On the other hand, if you have those that compile to intermediate language, to bytecode, like Java, .NET environment. This is Microsoft environment where we have common language runtime, which is the virtual machine and all libraries that comes around that. That is used for C# and Java and other languages. So this is, of course, improved every day because there is permanent group of people who works on Java virtual machines. So it becomes better and better. And same is with Microsoft Common Language Runtime. These are two same ideas. So why we have virtual machines? Not to make the life easier, but to make the language developer life easier. So if you have a virtual machine, then you have various source languages, language 1, language 2, language 3. Then you have compilers that compile from this source language to common intermediate language. This is called bytecode or common language runtime that is used. And then this is executed by the virtual machine, by this runtime. And it works on a hardware platform. So the idea is this, that to write a compiler that always compiles to this same intermediate language is much easier than have a source language that compiles first to some quadruples, and then it has lexical, syntax, semantic analyzer, creates an intermediate code, and then you have code generator, and then you have optimizer, all that sits inside the compiler. And this, of course, is very difficult to write, particularly various optimization procedures. So it is much better if you can have that somehow inside the virtual machine, and then you just compile to this intermediate language, cross your finger, and it is going to be good if these guys who write virtual machine are improving things all time. So execution of Java bytecodes using Java virtual machine is an example of that. And then you have also just-in-time compilation. So if you have loop that something repeats over and over again, you can quickly produce machine code for that and then execute it faster. So there are various tricks to make it faster, but the idea of virtual machine is to have easy production of different compilers for different languages. And this is what is obtained. Another thing also, this Java virtual machine or any kind of common language runtime is used for safety also. So you can have security features that are built inside, and this gives you advantages with respect to languages that gives you pointers with which you can directly attack hardware. So that malicious software can be written much easier than if you have virtual machine. Languages that execute directly as an interpreter, JavaScript, for example, Perl, Python, Ruby, PHP, all of them had scripting languages, all of them had interpreters. And languages like Prolog and Scheme are also working with interpreters. So no compilation. There are scripting features, efficient interaction with operating system environment. You can have advanced object-oriented features that are easily implemented. It is high level, independence of hardware, and relatively low performance. So performance ranking, number one, top of the food chain, assembly language. It is beautiful, but you have no money to pay programmers who will do in assembly language something, because this is 5 times more expensive than working in compiled language. So C or similar languages are much easier to develop software than in assembly language. Then you have bytecode, like virtual machine based languages, Ruby 1.9 up to this 2.7.2 that is yesterday available. Scripting languages executed by interpreter, this is Ruby 1.8. So program speed ratios, assembly languages between 1.5 to 9 times faster than compiled languages. That's typical. Compiled languages are from 1.5 to 3 times faster than those that run with virtual machine. Then you have that virtual machine versus scripting languages 1 to 10. When Ruby introduced this YARV virtual machine, they said that it is going to be 3 to 4 times faster. I was measuring this. It was 3 point something. So I think this is true, that it is between 3 and 4 times faster than Ruby script. Characteristics of Ruby. Author is Yukihiro Matsumoto. It is open source. Ruby is written in C, as it should be. All professional software is written in C, so that you can have high performance. So this is also true with Ruby. It is object-oriented. All data are objects. All operations are methods. It is suitable for procedural, functional, and object-oriented programming. And it has fantastic support for all three things built in a single language. It is compiled to bytecode and modern language with high expressive power. It has plenty of options. There is not a small language. It is not like Prolog where everything fits on 2 pages. It is not fitting on 2 pages. It has big book, but it has extremely high expressive power. This is few words about virtual machine. And what is the meaning of object-oriented in Ruby? All data are objects, integers, floating point, character strings, arrays, hashes, files, everything is an object. Objects are manipulated with their methods. So you say object.method, and that returns another object. And then object.method.method.method.method. What is this? This is non-procedural programming. You say what has to be done, not how to do it. So apply chain of methods to an object. Each method creates another object, and then this object is processed by the next method, and so on and so forth. It has strict encapsulation. You cannot access internal state of an object except through accessor methods. So you have to have accessor to object, and then you can manipulate object. You cannot do that directly. You have to go, it is encapsulated. Now, it is very easy to write short procedural code without necessarily creating classes and objects, very different from Java. And it is easy to create subroutines outside of any class that are accessible everywhere. So these are all excellent features. And the idea, the philosophy of the language is that Ruby borrows good concepts from many languages. So it is simply borrowing or stealing any way you want from Lisp, Perl, Smalltalk, and expands that. For example, you remember printf, that's print function that is used in C for printing files and to printing on the screen. And printf is directly taken from C. So the way it works at C, you have it here. Power operator, so base to power is written with double asterisk, same as in Fortran. So this is directly taken from Fortran. It has recognizers taken from Scheme. Actually, Matsumoto himself was to be for many years the Lisp programmer. He was working with functional languages. And then when he developed his own language, he wanted to have all these tricks that you have in Lisp or schemes. So you are going to see them available in an object-oriented language. So that's a good thing. Recognizers are among them. So you have recognize a function with question mark at the end that recognizes whether something is an object of specific type. Control structures, for example, ternary operator, question mark, and colon is directly taken from C, works the same way. Then you have octal and hexadecimal numbers that are also taken from C, and many other things. So you can say that Ruby is a superset of good features of many languages, and that is true. Now, resources, as I said, you have this Flanagan Matsumoto book, Ruby Programming Language, that is good for people as a reference for people who know language. If you want some free books, here are a couple of them. You have also Ruby Language Org that has plenty of resources inside. And I very much recommend this Dave Thomas book, Programming Ruby, Pragmatic Programmer's Guide. This is this book called Pickaxe. and has various editions. And usually the previous editions can be purchased for nothing on the internet as a used book. So I very much recommend that you do that. There are online free tutorials and free books. Some of them are also posted on iLearn. And I'm going to make this available so that you can copy from there if you want, but you can copy directly from internet, which is free and perfectly available. These books, Little Ruby Book and The Road to Ruby, are free and downloadable books. You can take them from various places. Then how to install Ruby. That's the first thing. If you have not installed Ruby so far, you have to install it. And that's what I did yesterday because this is a new machine. I don't have Ruby on it. So what I discovered yesterday, that the current version is 2.7.2. 2.7.2 is the current version as of yesterday. And for example, in December 2016, I installed 2.3.3 that has 18 megabytes size. Currently, if you want to take absolutely everything that exists in that package, all libraries, all additional features, all other support, it is 134 megabytes. So that's what I downloaded yesterday. So 2.7.2 is the version, 134 megabytes, and it installs very quickly on your machine. So you go to this place called Ruby Installer, rubyinstaller.org. And then you go to downloads. So first go to rubyinstaller.org, then go to downloads, and then they give you this screen here. Then it says which version to download. What you are going to get now is at the top 2.7.2, and will say if you don't know what to download, download this one. So click on this. It is going to take this 134 megabytes, bring to your machine, and then you click on that installer. And then it starts installing step by step. You have to do nothing but to wait a few seconds, and after that, you have to click here to install also this MySys development tool chain if you want to have it, and then after that you click on finish. And you have websites where you go for support, and you have also various other support for Ruby, because there are plenty of Ruby support on the internet. And when you have that, you can start to use Ruby. So one way to use it, let me show you how to do that, is to use simply command prompt window. Open the command prompt window, and then you will get a window like this here. And I have it somewhere here. Let me see. Can I share that with you? This one here. Okay. So it gives you the possibility to write same way as in, do you see this screen? Can you tell? For example, I enter number 5.
Yes.
And it replies. So what is this? This is the same as Racket or a scheme. You have prompt and you enter the value and it returns this value. Okay, so you can say, let me see whether it can add values, 1 plus 2 plus 3. What's going to happen now? It is going to return 6. So you can use it as a calculator, okay? You can also ask whether you can compute 2 to 4, for example, not 2 times 4, okay, 2 times 4, 8. And if you want to have 2 to power 4, then put 2 asterisk, this is power function. 2 to 4 is 16, okay? So you can also divide 1 divided by 3, okay? And you get 0. So if you say 3 divided by 2, get 1. So what is this? This is integer division. So integer division is available. If you want to have 3, which is a real number. So you have to put 0 after that. It becomes red. Because why you have to put 0? Because if you put 3 dot, 3 is an object, and dot is separator between object and method. And now Ruby accepts, expect method. So if you put method, it is going to apply to 3. But if you put 0, then Ruby understands that this is floating point number. So you have to put this 0. Divided by 2, 0. Okay. 3 divided by 2 is 1.5. So you work with real numbers, and real numbers are visible here. Okay. So you can also try to see what kind of numbers we have here and how this works. So you can say, let me put 1, and let me divide that by, whoops, let me divide that by 0. I always wanted to divide 1 by 0. What is going to result? Infinity. It is not going to break it. It is not going to make any error, but will tell you the result is infinity. And this is something that IEEE standard is supporting. You can also say, another thing that I always wanted to divide is 0 divided by 0. What happens in that case? You get not a number. So this is not a number because it is undefined value. Everything multiplied by 0 gives 0. So practically it is not a number. So 1 divided by 0, 0 divided by 0 are completely legitimate things that you can do. Not surprisingly, you will also be able to define variables. So you can say variable n equals 5. Here we go. What happens here? I say n equals 5. Why you are telling me 5? Because this smells as functional programming. This is an expression, but expression returns a value. So when I say n equals 5, what I have here that it is returned is 5. So if I say print, for example, print n, okay, what happens? You get 5, but you also have nil. So maybe I put here n and put here, let us say, a new line after that. Okay. So print n and print new line. What you get? Print command say take the variable n, object n, and display it. So here is displayed 5. But then you put new line, that's fine. But this is a functional programming construct, and this print n has to return something because it is an expression. And what is returned by a print statement? Nothing. It is just making side effects. So this is nil that comes out. So the meaning of this nil is you are executing an expression. Side effect is this 5. And this is what is returned as the result. Is this clear? That it smells as functional programming. Of course, you can say, let me define maybe k, which is equal to n. Okay. Now n was 5. Okay. So k is now going to be equal to n equal to 5. So I am not asking you to tell me that the result is 5. But this is an expression, and the expression returns a value. So same as print statement returns nil, this expression returns 5 because it is an expression that returns a value. Of course, you can say A equals B equals C equals, and all of them are going to be 5. Okay. You can also write little programs if you want. So you can say define factorial, so f of n. What is this? A function. Define function f of n. Look how simple is this. Function f of argument n, nothing else. You don't say what is the data type of n, what is the data type of function. No, this stupidity is integer f of integer n, ampersand, blah, blah, blah. Nothing like that. And then you also said if n is less than 2, so factorial, of n is going to be 1. So if fn is less than 2, return 1. In all other cases, what should we return? Well, return n multiplied by f of n minus 1. So that's what we have to return in this case. So we define function f of n in n is less than 2, return 1. So if n is 1 or n is 0, return 1. In all other cases, return n times f of n minus 1. And since this is the beginning of the function, you have to say where is the end of function. So here we go. We created the function f of n. So now I can say, tell me what is factorial of n, of 5, for example, like this. So factorial of 5, 1 times 2 times 3 times 4 times 5 is 120. Okay. You can also say, tell me what is factorial of n, because we said n is 5, and it is 120 also. So factorial works like this. This smells as functional programming. If you say apply function f to variable n, you get 120 again. So this pair of parentheses is optional. You can put it if you like to see function of argument, but no need for that. You can say this is operator f, and this is operand. Apply operator to operand, get 120. So that's perfectly okay. You can also say, tell me what is factorial of 5 with our function. So factorial of 5 is 120. Perfect. So the next step is check what is factorial of 50. Well, factorial of 50 is this huge number. So what we have learned here, that this same as a scheme does not have limit on integers. It is having integers of any size. So if you are encouraged by that, try to find what is factorial of 500. Here it is. You always wanted to see 500 factorials. Here we go. Here are 500 factorials. Okay. So practically, what you have in this case is a language that is very easy to use, easy to define, even in this interpretative mode. We are, of course, not going to use this for software development, but for testing and for playing games, it is perfectly okay. And you can do a variety of things with it. And so on this prompt, you can write functions and do variety of other things. There are also possibility to use some global variables. For example, when you say version, it is not returning to, it should be able to do that, but you have to print the version, obviously. So let me see, is this going to work? No, it is 272, but it is not giving me here. It used to give the version, if you say just version as a constant, it used to give in 266. You have it in the reader, but it is not giving here. Okay. So anyhow, this is the way how you can use Ruby, and related to these big numbers, we can say that the way how this works, if the value is small, for example, if you have factorial of 0, for example, that is 1, or if you have factorial of 1, 2, 3, which is very big, Ruby will automatically go from binary representation of numbers that fit in 32-bit format to scheme interpretation of numbers that have arbitrary number of digits. Of course, if you are working with smaller integers, this is going to be faster than if you are working with huge integers. This is going to be slower. So it is that way. You also have some constants that are available in various classes. We are going to see them in a minute. So what is the way how to work with Ruby? Let us go back to our reader and let us see how to install Ruby and how to use it in real life. So we have, let me go here. So to use Ruby as interpreter, you can have this, what we did as a demo. And one thing that they didn't do, but I could do, is to multiply string times an integer. So you have some new things that were not available in previous languages. So when you multiply string, but integer, welcome times 5, you get 5 times welcome, 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 welcome. If you want to make a loop, you say, I'm going to make a loop starting from 1. And then this dot here is the object dot method. So I'm going to apply to object 1 method up to. So up to means increment up to 3. So this is going to create 1, 2, 3. 1 up to 3. So up to is a method applied to object 1. And then you get that these values are stored in this n. These two vertical lines are not absolute value, but the place where you store this n. And then put string n. Put string is converting this n to string, printing and adding new line. So it is printing 1, 2, 3. And then this returns this 1, the first value. You can say also, let us change this 1 up to 3. Put this then in n and then print n square. And then you get 149. Okay. You can also have comments. So pound sign tells you that this is comment. Okay. Another thing, when you install Ruby, you can execute Ruby using this Ruby -e, which is a single line of code. This is just for testing purposes or as a calculator. You can have Ruby minus execution of a single line of code. So you can say, what 2 to 60, and you get it immediately as from calculator. On the other hand, if you say Ruby and put program Ruby, it is going to compile and execute your program. So the way to regularly execute the program, executing a Ruby program, is to write program using some kind of editor. And I'm using Notepad++. Notepad++ is a nice editor for programmers that can prepare programs in all possible languages. For example, for Scheme, I very much recommend that you use Notepad++.
Did he freeze?
Yeah.